Electrics. Hello guys, welcome to Electrics. Welcome an exciting Arduino project on our channel. In this video, we'll be diving into the fascinating world of light-activated electronics as we create a circuit that automatically controls and LED based on the surrounding light level. Get ready to explore the power of Arduino programming. Have you ever wanted to create a device that adapts to the changing lighting conditions around it? Imagine an LED that turns on as the room gets darker or automatically switches off when sunlight streams in. With our light-activated LED project, you can do just that. To make this project a reality, we'll be using a photoresistor, also known as an LDR, to measure the intensity of light in its environment. As the light level changes, the photoresistor's resistance alters, allowing us to control the behavior of an LED connected to our Arduino board. Throughout this video, we'll guide you step by step through the circuit setup, explain the coding involved, and showcase the final results. Whether you're a beginner exploring the Arduino world or an electronics enthusiast looking to expand your knowledge, this project is an ideal starting point. So, grab your Arduino board, photoresistor, and other components as we embark on this light-responsive journey together. Get ready to illuminate your projects with the power of light-activated electronics. But before we begin, let's take a look at the components we'll need for our light-activated LED project. First, we'll need an Arduino board, which serves as the brain of our project. You can use any Arduino board model you have available, such as the Arduino Uno or Arduino Nano. Next, we'll need a photoresistor, also known as a light-dependent resistor or LDR. This component senses the intensity of light in its environment and changes its resistance accordingly. We'll also need a resistor to create a voltage divider circuit. With the photoresistor, the resistor helps ensure proper readings and stability to make our circuit connections neat and organized. We'll utilize a breadboard. It provides a convenient platform for prototyping our project. Of course, we can't forget the star of our project, an LED light-emitting diode. This is the component that will light up or turn off based on the light level detected by the photoresistor. To establish the necessary electrical connections, we'll use jumper wires. These wires come in different lengths and colors, making it easy to connect our components on the breadboard. Lastly, we'll need a USB cable to connect our Arduino board to a computer for uploading our code and powering the circuit. With these components in hand, we have everything we need to bring our light-activated LED project to life. Now, let's move on to setting up our circuit. Now that we have gathered all the necessary components, let's move on to setting up our circuit. Follow these steps to get your light-activated LED circuit ready for action. Step 1. Place your Arduino board on the breadboard, ensuring that it straddles the center line with the pins aligned with the breadboard's power rails. Step 2. Take the photoresistor and insert one leg into the same row as the Arduino's 5 volts pin. Connect the other leg to one leg of the resistor. Finally, connect the remaining leg of the resistor to the Arduino's GND pin. Step 3. Place the LED on the breadboard, ensuring that the longer leg, the positive or anode leg, is connected to a resistor. Connect the other leg of the LED to the Arduino's digital pin 13. Step 4. Connect a jumper wire from the junction of the photoresistor and resistor to the Arduino's analog pin A0. This completes the voltage divider circuit. Step 5. Finally, connect your Arduino board to your computer using a USB cable to provide power to the circuit and allow us to upload the code. And there you have it. Our light-activated LED circuit is now set up and ready to go. Take a moment to ensure that all the connections are secure and properly placed on the breadboard. In the next segment, we'll dive into the programming aspect and bring our circuit to life, so stay tuned. Let's explore the Arduino code and understand how it enables our LED to respond to changes in light intensity. We'll be using the Arduino integrated development environment to write and upload our code to the Arduino board. If you haven't already installed it, you can download it for free from the Arduino website. Open a new sketch in the Arduino IDE and let's get started. First, we need to define a few variables. We'll create a variable to store the analog input pin number that is connected to our photoresistor. Let's name it Light-Dependant. In our case, we'll set it to AO, which corresponds to analog pin 0. Next, we'll declare another variable to store the analog value read from the photoresistor. We'll name it Light-Value. Moving on, we'll define a constant variable named LED-pin to store the digital pin number. Connected to our LED, we'll set it to pin 13, but you can choose a different pin if you prefer. Now, inside the void setup function, we'll set the LED pin as an output using the pin mode function. We'll also open the serial communication at a baud rate of 9600, so we can monitor the readings in the serial monitor. With the setup complete, we move to the main void loop function here. We'll read the analog value from the photoresistor using the analog read function and store it in the Light-Value variable. Next, we'll use the if statement to check the Light-Value against a threshold value. If the light intensity falls below the threshold, we'll turn on the LED using the digital write function. Conversely, if the light intensity is above the threshold, we'll turn off the LED using the same digital write function. And that's the essence of our Arduino code. It continuously reads the analog value from the photoresistor and controls the LED based on the light intensity it detects. In the next segment, we'll upload the code to the Arduino board and witness the light-activated LED project in action. Stay tuned. With our code written, it's time to upload it to the Arduino board and test our light-activated LED project. Follow these steps to upload the code and witness the magic happen. Step 1. Connect your Arduino board to your computer. Using the USB cable, ensure that the board is properly powered. Step 2. In the Arduino IDE, click on the Upload button or go to Sketch and select Upload to compile and upload the code to the Arduino board. Step 3. The code will now be compiled and uploaded to the Arduino board. Watch the status bar at the bottom of the Arduino IDE for progress updates. Step 4. Once the upload is complete, the Arduino board will start executing the code. You should see the LED responding to changes in light intensity. Step 5. To monitor the readings from the photoresistor, open the serial monitor in the Arduino IDE. Go to Tools and select Serial Monitor or press Ctrl plus Shift plus M on your keyboard. Step 6. In the serial monitor, you'll see the light intensity readings displayed. This allows you to observe how the LED reacts to changes in light. And there you have it, our code is uploaded. And we can now see the light-activated LED project in action. Feel free to experiment with different light intensities and thresholds to fine-tune the behavior of your project. Have fun exploring the possibilities.